So in this video, we're going to look at arc length of a circle. So we've already written the equation for arc length, but I wanted to go over kind of logically how we came up with that equation. S equals r theta. So let's start off with a circle. And let's say we're going to go from this point here to this point there. Okay, so the circle does have a radius r, and we rotate theta degrees, and the distance from here to here is s, or our arc length. All right, so now just to remind ourselves, we've learned this in geometry and in other classes, but arc length in essence is if I were to take a piece of string and go along the curve here, and then I take that piece of string, raise it, and flatten it out, and then put it on a ruler, that would be the arc length. So if you imagine this as a really, really big track, you could think about if you're running around it, what's the distance, the curved distance that you're actually running. So that's kind of an idea of how arc length, what arc length is. All right, so now let's see how we get this formula for arc length. And what we do is we're going to look at the arc length of a complete circle. A full circle. So if I were to start here and go all the way around, what is that distance? And when you talk about the arc length of a circle, that is the circumference. So in this case, S, which is our arc length, there should be a T up there, is equal to the circumference, which is 2 pi r. Okay, so the arc length of a full circle is 2 pi r. But we don't have a full circle. We only have this much here. And so to get the arc length from this point to this point, I'm going to call this A and this B. To get the arc length from A to B, what we do is we think about the idea that we have a fraction of the circle. Like if this were just a quarter of the circle, it would be easy because you take 2 pi r and divide it by 4. But let's say we don't have a quarter. Let's say it's just, say, some angle theta. Well, what we're going to do is we're going to multiply this arc length of a full circle by some fraction. So, multiply by a fraction of the circle. And so this fraction is going to be the angle measure over the total possible angle measure. And so in this case, our angle measure is theta, and then the total possible angle measure is, well, how many radians are in a full revolution? And that is 2 pi. All right, so I guess that's one thing we need to clarify. This formula is based on radians. So this formula is based on radians. I'm going to put a box around the word radians. You got to get used to using radians. All right, so now we can look at the arc length as equal to our fraction times the circumference. And so that's going to be theta over 2 pi, that's our fraction, times the circumference, which is 2 pi r. Well, when we multiply it out, the 2 pi r's conveniently cancel out, and we end up with theta times r, or what we write as r theta. So our arc length equals S, which is r theta. And there is our formula. All right, so it's a fairly basic formula, S equals R theta, and it just comes from the idea that we are taking a certain fraction of the circle. And I'm going to write this again just to be clear. This is in radians. If you want to do it for degrees, you got to come up with another formula. Okay, so let's look at an example. A circle has a radius of 27 inches. So that's a pretty decent sized circle. Find the length of the arc intercepted, oops, I got it in there, by a central angle of 160 degrees. All right, so let's take a look at this. Here's our circle. It has a radius of 27 inches, and we have an angle of 160 degrees. And so we want to know, what is the distance from here to there? S. All right, so we start off with S equals R theta. R, that's easy enough, 27 inches, it's given. Theta is 160 degrees. All right. So let's see, we take out our calculator and we say 27 times 160, 4,320 inches. And you kind of look at that and think, wait a second, that makes no sense. How can a circle with a radius of 27 inches have an arc length of 4,000 inches? Oh, wait a second here. This is in degrees. And what did I write up here? This formula is based on radians. Radians. See, I even forgot it myself from going from here to there. Actually, that's not true. But anyways, now that we have that, we realize that this is in degrees and we need to be in radians. The next thing we need to do is convert this from degrees to radians, and we know how to do that. We take our degree measure and we multiply by pi over 180. All right, so let's see here. I'm going to go ahead and see if I can simplify this to 27 times 160 divided by, does it divide evenly by 180? It does. So we get 24 pi inches. Now, because it's a, depending on the problem, if it's just a basic problem and you don't have a calculator, there it is. If you do have a calculator, sometimes it's nice to get a decimal equivalent, especially if it's a word problem. So we're just going to go ahead and multiply that by pi, and we're going to have 75.40 inches. And so both of these are correct. It's sometimes nice just to give both of those answers so we are clear. All right, so there's arc length. Arc length, very basic formula, S equals R theta. Biggest thing to remember is that theta is in radians. So if you're given a problem in degrees, you do have to convert the degrees to radians.